I didn't say anything. Go. You're on.
Hello. Welcome, folks. This is the stpete.net meetup. I'm John Calloway. Clayton Hunt is controlling video.
It's my fault.
Jesse Liberty is joining us.
Which way is that? That's how you do it.
He'll be presenting on Git in 45 minutes, and we were discussing that if he likes, we can continue on the conversation longer than 45 minutes. So chat, feel free to ask any questions in the chat, and we'll make sure to get those addressed from Jesse. And so if you have anything at all, we, AI, the PAL78, apologies if I'm butchering your name, we will be backing up this this live stream on Twitch to our YouTube channel as well. Let me go ahead and drop the link to the stpete.net meetup YouTube.
Yeah, I'm thinking Owl the Pal.
Yeah, I'm terrible. I'm sorry. I couldn't tell if it was an I or an L and, tech, and we're thinking AI all the time.
Fonts are hard.
Yep. And apologies, we have been missing the stream and the guests and the presentations and the meetup for a couple of months now. Both myself and Clayton, dealing with some health issues. If you can't tell, I am struggling with some dental issues at the moment as well. So apologies for any slurred speech, any more so than normal. This is stpete.net meetup. We do try to meet either virtually or in person, back when that was a thing, monthly, the second Tuesday of the month, usually. Even if we were in person, we would also be streaming to Twitch as well, so that if you weren't in our area, that you could still participate and get the gist of the presentations. Jesse, where are you joining us from this evening?
I'm in Acton, Massachusetts,
Nice.
which is about an hour northwest of Boston. If you go out in northwest, you'll pass Lexington and then Concord and then Acton.
Very nice.
Very revolutionary place.
That's what I hear. My son is 9 years old, and they're starting to learn about things. So I'm reminded of that America has a history, and we should probably remember it and so forth. I apologize. My humor is dad humor at this point in my life. So Al the Pal says, I am from Worcester, but live in Tampa now. So awesome. So yeah, welcome. Chat, let us know where you are, where you're joining us from. Clayton is a little bit south of Tampa. I'm a little bit north of Tampa. I see
Your last person will be very unhappy with Worcester. It's Worcester.
Oh, I'm sorry.
That's quite all right. Nobody knows how to do it.
Oh, that's the sauce that you can't pronounce, and you only buy one of in your entire life, and it never runs out.
Up here, if you see Leominster, which you would be tempted to say Leominster, is actually Laminster. There's quite a few of those.
Well, I used to live in Louisville, Kentucky. That's Louisville to the rest of the world.
How do you say it?
Louisville.
Louisville.
Yeah.
Okay.
Right down the road. I actually grew up in Frankfort, Kentucky, right down the road from Versailles, Kentucky. That would be Versailles to the rest of the world.
Yeah. Well, so it's Versailles, Indiana, Versailles, Kentucky, and they're not very far apart.
That's good.
And Athens, Georgia, and Athens, Kentucky.
My favorite is Des Plaines, which you would expect to be Des Plaines, but they insist it's Des Plaines.
Okay. Well, we're about 6 minutes past the hour. Do you want to say, again, welcome. This is stpete.net meetup. We will be passing the mic and the camera and the presentation over to Jesse Liberty, who will be talking about Git in 45 minutes.
I'm plugging my book relentlessly, but
yes,
go ahead.
Absolutely. We are continuing to look for additional presentations, additional speakers. So if you know of a topic that you would like to hear, if you know of a topic you would like to present on, if you want to volunteer yourself or volunteer a coworker, let us know. We would be happy to have anyone present on just about anything related to technology and maybe approaching something around .NET. We, of course, are live broadcasting on Twitch this evening, and we'll back up the video to YouTube as well. So if you don't catch us live on Twitch. You can join us on YouTube as well. Do join us on Meetup and be sure to RSVP there and join in any of the conversations that we might be having in the discussions on Meetup. We also have a Facebook group if you're into that sort of thing, or follow us on Twitter. So with that, Jesse, you want to go ahead and take over for us?
Sure. The thing about Git is that a lot of people approach it with a lot of fear. And Git is really not terribly hard to learn. The approach that I took in my book and that I take in these presentations is to avoid talking about how Git works internally. Most people who are teaching Git start with the internals of Git. And about 12 minutes into that presentation, about a third of the people run screaming from the room. So I believe that you can use Git and use it well and not get yourself into a corner without knowing the internals. So today we're going to talk about how you use it and what some of the commands are and how to make it a little bit easier. Because in fact, let's see if I can have it, it's much easier than most people say, at least most of the time. So let's start at the beginning. What is Git? I don't know how technical the folks who are watching are. I assume they're fairly technical, so I'll go through this part fairly quickly. It's a version control system. The idea behind a version control system, when I started programming, the way I would manage my code so as to be able to go back if I messed something up would be to make a complete copy of the entire directory and then do some programming and make another complete copy of the entire directory. Git essentially does that, but incredibly faster and with far less use of your disk. But it does allow you to go back to a working version, a previous version. It also allows you to switch among tasks quickly and safely. So if you're working on a feature and then someone comes and tells you about a bug, you can very easily go over to fixing the bug and then go right back to where you were. Git makes that very easy to do. And then the third thing is it makes it easy to share code so that if you're on a team, you can work on your feature and someone else can work on their feature, and then we can merge them together. And all of that is at least safe to do and often very easy to do. We're going to get into how you do some of that. A key thing to remember about Git that is very hard to wrap your head around is that most things happen locally on your own machine. It looks at times like everything is happening up in the cloud, but really the heart of Git is local. This second point is probably the most important point of the evening. You really have to go out of your way to lose your work with Git. There are some advanced commands that are dangerous. Git will warn you about them before you use them. But really, you can go happily through your entire professional life and never lose work with Git. There are certain areas, conceptual areas with Git. There's the work area, staging, we're going to talk about each of these. The repo on your machine, that is the repository on your machine. The remote repository, if you have one, and the stash. So these are the key areas that we're going to talk about and that really comprise Git. Let's talk first about the work area. The work area is simply the current files in your current directory. It's what you'll see if you open Visual Studio. Now, when you're working with Git, that can get really weird because you do some work and you put it away in your repository and you take down other work and, you know, what's in my work area? Or are they both in my work area? And the thing to really keep in mind about your work area is there's one version of your code at a time in your work area. And you can see that version either by going to your File Explorer or Finder or however you look at your local files, or by opening up Visual Studio to the application and seeing what's in Solution Explorer. So that's another thing that if you walk away with anything you want to walk away with this is that you only have one thing at a time in your work area. Index and staging, one way that many people like to work is that they will have things that they've modified, but they're not ready to commit. And we're going to talk about what committing is. So they will index some of their files and say, these are the ones that I want to put into my repository, and the others I don't. Now, I will tell you that when I'm working, I almost never use the index. Other people use it every time they work. So there's a wide range of usage patterns on how you use the index. And we'll look at that as well in a moment. Repository is on your machine. The idea of a repository is that's where all the versions of your program sit. And that is sort of a frightening concept because everything's in there. But if you use any kind of repository in the cloud, such as GitHub or Azure, then your files are in your local machine, but also safely in the cloud. One of the things that separates Git from other version control systems is that it is distributed. So unlike others where the golden copy is on the server and you have to bring it down every time you want to do anything, in Git, everything is on your machine and everyone else's machine, and it's very easy to synchronize everybody. So should you lose all of your work, let's say your computer explodes, it's very easy to get back into business, except for maybe the small amount that you were working on that you hadn't yet committed. And you can do that even without having a repository in the cloud. If there were 3 of you on the team and you're working distributed, you can recreate repository from someone else's repository. Obviously, that's much easier to do if you have a repository in the cloud, because then you can just pull it down. When I was talking about having a repository in the cloud, that's often referred to as a remote repository. The remote repository is essentially the same thing as your local repository. The difference is that because it's up on GitHub or Azure or some other cloud-based repository, it's much easier for other people on your team to get the code that you were working on, that you've checked in and pushed. And what push means is simply that you've taken your code and put it on the remote repository. We're going to look at those relationships in just a minute. If you're working and you are not ready to commit your code, you're not ready to put it in the repository, but you need to change to do something else, you can temporarily put all of your code in the stash. And it is just what it sounds like. You stash away your code and then you come back later and pop the stash and go back to what you were doing. So let's talk about that word commit that I've been using. A commit is simply saying, take the code that I have on my work area and move it over to the repository on my local machine. Once I have it on my local machine, if I want to get it onto the remote repository, I push. And the concept here is that you're pushing the data in your repository up into the cloud. And not surprisingly, when you take it down from the cloud, that's called a pull. When you commit, one of the things that you're asked for is a message that explains what you've committed. Those messages are very, very important, especially if you're on a team, but even if you're not, because when you go back to look at what you've done and where you did it and when you did it, those messages are going to be the key indicator of what's in that commit. There is a convention to put messages in the imperative. So instead of saying added some files, you would instead say add some files. In addition, there's a very strong imperative to use as specific a message as you can. So rather than some files, you might say the calculator class. So you can see the difference between those two. There is a concept called interactive rebase, which we'll talk about later, that allows you to clean this up if you get it wrong. but it's important to get into the practice of good commit messages. There are a number of ways to use Git. We're going to talk about the command line, and we're also going to talk, I think, about Visual Studio, which has become increasingly powerful for working with Git. If you're going to use the command line and you're on Windows, you're probably going to be using PowerShell. And if you are using PowerShell and you want it to look pretty like this, which tells you what branch you're on, we'll talk about branches, and it will have little indicators telling you how many files were modified and how many files need to go up to the cloud and so forth. I recommend highly that you go to this article, which I have shortened to jliberty.me/prettygit. And that's an article by Scott Hanselman on how to do this. It's a very well done article. It takes you step by step. Okay, let's talk about getting started. And the starting point typically is to create your repository. Now, you can create your repository locally, or you can create your repository in the cloud and then pull it down. But once you have your repository, you're going to have a first commit. And that commit is going to be on what we call a branch. And you'll see that later there will be multiple branches. That branch is typically called main or master. There's also a pointer called head that points to the tip of a branch. Rather than working on main, all of your feature work, all of your debugging should happen on a branch. So you simply say, when you're on main, you simply give Git the command to branch and the name of the feature, and it will branch off from main and allow you to do work without any risk to the main branch, which is typically the branch that's going to go to production. So you could do a whole lot of work in this feature and then decide that you don't want it at all and throw it away without doing any damage to the main branch. This is one of those bootstrap problems that it's hard to talk about branches until you understand branches. Here we have main, and the arrow, you'll note, points down. Each commit points to its parent commit, and the parent commit is below it. And so this was the first commit on main, this was the second commit on main, and so forth. Off of the first commit on the main branch, we created the feature one branch, and there were 3 check-ins for that. And notice that head is pointing here to the third one, which is telling you that that's the branch you're on, and it's pointing to the tip of that branch. There are a couple ways to to switch branches and to get on to a different branch. One is to simply say git checkout and then give it the name of the branch you want to go to. You can also create a branch by saying get branch feature 2 that will create feature 2 but not move you to it. Then you would say get checkout feature 2 and that would move you to the branch. You can combine those, however, by that last command you see there, which is get checkout -b, which says create this branch and check it out for me. So now we have 3 branches. We have the main branch, we have the feature branch, and feature 2. And notice that feature 2 is branched off of the third check-in of main. So it's going to have everything that's in the first, second, and third check-in of main, and then its own work in feature 2, whereas feature 1 does not have what's in the second and third check-in in main because it branched off of the first. And we'll talk about how to solve that problem. When you check out a branch, that points the head at the tip of that branch. And all that means is that whatever is the latest work in that branch is going to be what's in your work area. That's what you're going to see when you go into Visual Studio, whatever your, what's the word I want? Whatever your, great. Lost the word. However you like to do your work. What is Visual Studio and Visual Studio Code and all of the IDE? Thank you. Whatever your integrated development environment is, that's what you're going to see is the typically when you check out a branch, you're going to see the most recent code for that branch. Okay, we talked about push and pull, which is to move the data on your repository locally up to the remote repository and then pulling it back down from the remote repository into your local repository. Similarly, when you want to get work into the repo on your machine, you commit. And when you want to get that work out of the repo and back into your work area, you check it out. Now, if you've been working on feature 1 and main has been moving along, at some point you're going to want to take your work on feature 1 and put it into main. The typical way to do that is with a merge. So you would check out feature 1, which will get you to the latest in feature 1, and simply say at the command line, get merge main. And that's going to merge the work you have with the latest work on main. Most organizations or large teams don't let you do that until it's been looked at by another developer. Because remember, main is where you're going to be distributing from typically. And so main is very precious and you don't want anything to be in there that isn't right. So you will, instead of merging, you will issue a pull request, usually called a PR. And what that says is, please, other members of my team, look at this code. And if you approve it, then we'll do the merge. And some teams require one person to look at it and some require 2 people and so forth. So that's what a pull request is all about. And you'll hear that a lot on open source software, that you'll check out code from the open source project and then you'll issue a PR and some owner of the overall project will approve that or not. Now, one possibility is that you have branched off of the latest check-in on main and then worked on your feature, but main hasn't progressed. In that case, when you merge, you can do what's called a fast forward. And what that says is, you can see here that this is essentially one trail and you're not missing anything from main, you're capturing everything. So fast forward says, when I merge, just move everything up to the last check-in of feature/main, and they will be merged, but it happens very, very quickly, and nothing will show up in your merge history because you don't need an actual classic merge. You're going to do this fast forward merge, and you want to do that whenever possible, but Git will figure that out for you. If, however, you branched off the second commit of main, and now you want to merge, but there's another commit already, there are 2 solutions to that problem. One is a merge, a true merge, where you create a new, just simply by saying merge, you're going to create a new commit essentially that says, take the latest in feature 1, merge it with main, and give me the result. And as you can imagine, you'll sometimes run into merge conflicts where this has changed the same thing that this has changed differently. And then you have to resolve those conflicts before you finish your merge. Another way to resolve the problem is to use rebase. Now, rebase is one of those concepts that really makes people run screaming from the room, but it is not nearly as difficult as it's made out to be. And the reason it seems difficult is because one way that it's described is, well, you're rewriting history. True, but not helpful. What's actually happening when you do a rebase is that we are going to change the the branch from pointing at this commit of main to this commit of main. And it does that by making a copy of every commit in feature 1 and putting them onto the top of main. So you would say merge into, but rebase onto. And you can see that you now have a direct string from the first commit of main all the way through. And that's typically shown like this. but that's just a convention. But it does emphasize the fact that feature 1 has everything in main to date. Rebasing. When you're rebasing, you get a much cleaner history when you're looking at your series of commits. When you merge, there's a commit for each time you merge. With rebasing, there is not. It also allows you to reduce conflicts, although you can do that with merging as well. But the idea is to commit very frequently and rebase very frequently, and that will make sure that you are not going to have conflicts when you finally do merge or rebase onto main. However, as great as rebasing is, and as really straightforward as it is, it's imperative never to rebase on the server. And this is where the concept of changing history comes in. When you rebase, what's actually happening is that those 3 check-ins are being copied and then put one on top of the other. If somebody else on your team was using one of these commits, branching off of it, and you change it on the server, you will break their code. They will not like you. They'll be very unhappy. They will hunt you down. So do not rebase on the server is what is sort of the consequence of that. And the way you do the rebase is you check out the branch that you want to rebase onto main, and then you say get rebase main. Now, everything I'm showing you right now is how you do it at the command line. An awful lot of this can be done through visual tools, GUIs. There are a lot of them. For me, the best at the moment is Visual Studio itself. They have made enormous strides in how Git is managed in Visual Studio, but there are a lot of other options. On the simpler side, there's GitHub Desktop. There are also a number of other GUI that show you exactly what the relationships are and how they get connected and how you merge and so forth. So it really is fielder's choice. But the advantage of the command line is that there's nothing in Git you can't do on the command line. You can, let me try that in English. You can do anything you can do in Git, you can do on the command line. That's not necessarily true of the GUI options. So another use of rebase is called interactive rebase. It's an unfortunate name because for all intents and purposes, they're completely different commands. What interactive rebase allows you to do is to take some of your commits and squash them together as if they were one commit and reword those messages that you wrote. And then if you want, remove some of the commits, reorder the commits. But what I use it for, and I think most people use it for 99% of the time, is you've made a bunch of commits, little commits, maybe work in progress commits, and you squash them all together into one commit. So you can see here that the command on the left is get rebase -I, which makes it interactive. And on the right, you can see that we have a number of commits that are ready to be pushed up to the server. But when we're done with the interactive rebase, we have only one. So we've squashed those 4, I can't quite see it on my screen. Yes, those 4 commits that were going to go up into one commit that's going to go up. You want, of course, to do the interactive rebase before you push. Once you push, you no longer have the option to do that. So when you're working, a typical order of operations is you create a branch, you write some code on that branch and commit it, and you do that again and again, write a little code, commit it, write some code and commit it. Then you might do an interactive rebase to clean up those commits. And then the next step is to fetch from main, get whatever is new on main and pull it down onto your local repo and rebase onto that or merge with that. And you're going to do that repeatedly. And the reason that you're rebasing frequently or merging frequently is because, as we said, there might be conflicts as you go off and work on one part and somebody else goes work on the same part, and you want to catch those really early. There's nothing more dispiriting than finding out you have 250 merge conflicts. When you're done, you're just going to you're just going to send the push command, which will send all of your work up to the cloud. And after that, typically what you're going to do is a pull, a PR, where you're requesting approval to merge into the main branch. Nope, we don't want that slide. A couple other things in Get that are useful. If you made a mistake on your very last commit and you have not yet pushed it, you can use the amend command, and that will allow you to, as you might guess, amend the most recent commit. If you need to amend something more than the most recent commit, then you would use interactive rebase. Aliasing is one of my favorite things. It's essentially like snippets are in a lot of IDEs. And you find them by going to your configuration file. And the easiest way to do that is to go to config, global, and edit. And that'll open up a file. But if you want to create an alias, all you need to do is say config and then global, because you want it to be throughout your project. And then the keyword alias, followed by a dot, followed by whatever your short snippet is going to be called. So I might have one called CO, and when I finish with this, I tell it checkout is what CO is going to stand for. I can then say get CO, and that's the same thing as writing get checkout. And they could be fairly simple and save some time, but they can also be a bit longer or combine some flags that you may not always remember. So I have one called BC for checkout -B, which you'll remember creates the branch and checks it out. And then because I can never remember whether I've done BC or CB, I made the same alias with CB. A very large alias that I stole from someone else is this. It is the log, and we'll talk about the log. And what it does is it takes the log and it adds all of these colors and indicators of what information you want. So I'll do it very briefly. You have %C, which means begin a color, and then cyan is the color. Then %H gives you the short hash value, and then %C reset is what turns that color off. These bars are going to be displayed, and so on. And when we run all of that, it comes out looking like this. Here's the hash, here's the bar, then in white is the message, and then in cyan is the person who checked it in, and then in yellow, how long ago they checked it in. And I find this to be very, very useful. You certainly don't have to do this, but being able to type get LG and getting all this information is great. If you want to create these all at once, or you want to edit what you have, rather than saying config global alias dot whatever, you can instead open up the file itself by saying get config -- edit -- global. Now this didn't come out right, but those are 2 dashes. Let's talk about that log. The log is a very powerful tool for understanding what's going on in your repository. One thing that you can do with get log is you can add -- one line, and then it will give you one line for each commit, which greatly makes it much easier to be able to see what has happened in your series of commits. You can ask for the name only, which will give you, as you can see here, the names of the files changed in each commit, which can also be very useful. This is -1 says I want the last commit, and this is the pretty is very much what I was showing you in the previous slide about making an attractive printout. -P with the log will just show you what's changed. Use that a lot. Very helpful and informative. You can also just ask what changed in a single file. You can search for strings with -- capital S and then whatever you're searching for. And that will find all the commits that has the string that you said you want to search for. You can also check on all of the commits that were committed by an individual. And for that matter, you can check on all of the commits that were authored by a particular person. There's creating or authoring the file, and then there's committing it. You can constrain that by saying since equal and pretty much any reasonable phrase for a time span. So this will say, find everything that Jesse created in the last week. One of the uses of log that I use a lot is I want to find everything I've committed but have not yet pushed. And this use of get log, as you can see here from origin ... head, says exactly that. Find everything that's committed but not yet pushed. And then I put it on one line so that I can see all of those on one screen. Here's a couple other useful commands. I suspect that I'm going to finish earlier than we had planned. No questions along the way? Maybe I put everybody to sleep.
No, there's been a few questions along the way, mostly about preferences around tools and such. And we've been kind of carrying on a little conversation about whether we use Git Bash, PowerShell. Some of us use just regular command window and then got scolded for it. That was me.
Then there's Source Tree, which is a GUI, and there's GitHub Desktop, and I'm trying to remember all the other GUIs. There's Fork, which is a relatively new GUI that a lot of people really like. I'm sorry?
Git Kraken is one that I've heard a lot about.
It depends a lot on how much help you want in the GUI and how comfortable you are with the commands. And so there's a Get Tortoise, extremely powerful GUI, but you really need to know Git pretty well to take advantage of it, to use it to its best. Okay, a couple other useful commands. One very powerful command is Git Restore, which you can add a file name to, or just dot, which means restore everything. And what that does is, well, you can see here, if it's without any flag, it's going to discard the changes to a file or to your directory. Now, obviously, this is one where you could lose work. The work that you would lose is all of the work you've done since the last commit. That may be exactly what you want. I'm working on something, I went down a dead end, I really don't want to save this, I just want to get back to my last commit. Fine, you say Git Restore, and then either a file name, or if you really have like everything that you've done since the last commit, you're really sure you don't want it, then you can just say Git Restore dot, and that will return you to the most recent commit. Git Show is a way to see everything in this upcoming commit. And I believe it shows also previous commits and shows you things like who committed it and what files are in it, and I don't really actually remember. Git Blame, poorly named, shows you every change in a commit and who made that change and at what time. Ideally, this is not used so that you can go yell at that person, but it is often used to be able to go to someone and say, I need to use this code and I don't really understand this line or those lines, so can you help me with that? And Git Blame will show you who actually wrote those lines. Git Diff can be used before you commit, and that will show you what has changed in any file that's been modified. This is an example of something that is much more powerful and much easier to understand in a GUI, because it will show you in an ordered way, whereas at the command line, it just kind of flows out in one big screen. So I really like the way Visual Studio does Git Diff and Git Blame and a number of these. If you are using PowerShell, or I'm sorry, if you're using less, the Unix program that many people have in their bash environment, what do I want to say? Bash, what would you call that? Shell. You can use a command called less. Less is more. More is the old command. But what you can do in less is you can scroll up and down. So less is very useful if you just want to look at a file and you're not in a GUI. Okay, bisect. This is a very advanced command. It's a great command. It's one you want in your toolbox. This is when you've been working and you realize that something broke in the past and you don't know which commit broke it. You notice that things are no longer working. You go back to the previous commit, they're still no longer working. Okay, it happened some time ago. Before you panic, you can use bisect. And what bisect does is it asks you for the commit that you know was good, was working. And then it wants a known to be bad commit, which could be your last commit if you want. What it does is essentially a binary search for you. It'll cut the remaining commits in half and then put that in your work area and you can test it. Or if you have unit tests, it'll run them for you. And you do have unit tests. And it will work its way down and tell you how many more trials it has to have before it can find the commit that you want, that where the break happened. And that can save hours of searching through commits. So bisect, at least keep in the back of your mind, and you can always look it up when you need it. So here's an example of using bisect. You say get bisect start. That's how you begin the process. And then you say get bisect bad. And that says the current commit is bad. You could give it a SHA of a particular commit, but typically you just say get bisect bad, meaning the last one, this most recent one is bad. And then you go find the one that's good and you say get bisect good and you give it the short SHA of that good commit. And it will come up and tell you how many revisions there have been between the two. So therefore how many revisions it has to test. And it'll tell you how many steps it will take to get there at most. Whoops, sorry. You then test the version that bisect checks out for you. If it's bad, you say get bisect bad, and it will tell you how many revisions are left and how many steps are left. And at some point you will run out of commits, and bisect bad will point to the problem. And at that point, you can, if it's the most recent one, you can do a reset, or you can check out the original commit and branch off of that. There's a lot of things you can do at that point. I think that's what I have. There's a lot of Git documentation on the net. There's the official Git documentation, which I find extraordinarily difficult to read and understand, but there's a whole lot of other documentation by some very good writers who work through examples. There are a number of blogs. Mine is jesseliberty.com, and I have a number of blog posts on Git. There are podcasts, and I suppose I should mention that I have a book that just came out called Git for Programmers that takes you through all the material we just went through and more, and has a chapter on how to get yourself out of trouble when things don't go right. So that's pretty much what I have. I appreciate your letting me go through this. I know that I was talking at about half speed. But I have a new job and it's just sucking the life out of me. So I'm a little tired tonight.
That's what jobs are good at, though.
Yes, it's a great job. It's a great job. It's just,
congrats on the new job.
Thank you.
Yeah, we've got applause coming from chat. Continue sharing screen, and we'll go to the Talking Heads view, and if we need to switch back, we can do that as well. We dropped several links to your Twitter account, Jesse, to your website, and to your book on Amazon if you guys want to continue to fuel Jeff Bezos. I'm sure it's available other places
It's
as well.
available at independent bookstores, and since my wife works at an independent bookstore, Belmont
excellent.
Books in Massachusetts, I need to say that you can get it at a lot of indie bookstores.
Yes, so please do that. You can see the photo of it on Amazon, and then go look for it in your local bookstore and support them. So
That'll be a switch.
yeah. So and I think we agreed. It was Al the Pal said, "Awesome, learned a lot." Yeah, one of the things that I think last time that Jesse, you and I talked when you joined us on the podcast was about rebase and interactive rebase, and you actually answered some of the questions I had, which were you can do that as long as you don't push, and that's what I find that I do incorrectly sometimes. I'm a little too eager to push to the server before lunch or something like that, and then realized that, oh yeah, I had like 37 commits to my local branch before I did that, so I can't really clean up what I've already pushed.
Right. Once it's on the server, you really don't want to do rebase or interactive rebase.
Oh, yeah. One of the questions that came up was your short URL to Hanselman's post. It didn't appear to work. We tried to find one of them, found how to make a pretty prompt in Windows Terminal.
Okay. It may be that this is just old and out of date, and I'm looking for where it is. And we can do a search in Hanselman's site for whatever his latest is on Pretty Put. I'm supposed to stay in the slideshow.
Yeah, no, you're fine.
You're fine.
Okay.
We're on our.
I'll try to track down where it is and send that to you.
Yeah, so we found a link to a very lengthy title on Hanselman's blog, was how to make a pretty prompt in Windows Terminal with Powerline, Nerd Font, Cascadia Code, WSL, and Oh My Posh. So
Oh my goodness.
that is a way to do it. I'm sure there are others. I think Clayton put in a whole host of other tools.
So the Oh My Posh is based off of Oh My Bash, or no, Oh My Z Shell, and then Oh My Z Shell also has Oh My Bash as a spinoff, and probably Oh My any other shell that you want to use.
Right. And Roddy Pine says, "What does your shirt say?"
I'm not going to translate it. It's a geek shirt.
Stay at 127.0.0.1, wear a 255.255.255.0.
Exactly. Yeah, I didn't mean to make a political statement. It's just what I happen to be wearing today.
Yeah, I'm wearing my Game of Thrones Redis t-shirt, but I'm out of focus or out of shot, so you can't see that.
I'm just wearing a conference tee. From
which conference? That's the key thing.
It's old.
Okay.
It's from, I think this was from Codepalooza several years ago. I don't have any new conference t-shirts, unfortunately. My wardrobe is dying out.
Yep.
Yeah, well, we all missed the conference circuit.
Yep. I'm being forced to buy snarky shirts online instead of just picking them up.
All right, chat, last call for questions. If there's anything that Jesse touched on that you want more information on, I'm sure he's always willing to answer any questions on. Is Twitter the best place to get a hold of you or contact from your blog?
Probably my email, actually. It would be jesseliberty@gmail.com.
Okay, perfect. But yeah, so if you got any final questions you want to throw in chat, we'll stick around for another minute while the audio catches up on the stream. This video will stay around on Twitch for an additional week, and then Twitch will remove that for us, but we will be backing up to YouTube and giving that link out to Jesse and others and showing that to whoever wants it, making sure that it's available. Yeah, Roddy Pine says, we definitely read your book. I have a copy of it that I purchased when I heard about it. So I highly recommend that one. Yes. Yeah, again, support your local booksellers. Follow Jesse on Twitter and on his blog and email him if you have additional questions. This is the stpete.net meetup. We are trying to get back in regular rotation, live streaming once a month. If you have any suggestions or recommendations on topics you want to hear from us or hear from someone in particular, if you have a recommendation for a guest or you want to volunteer yourself or a coworker, just feel free to let us know. We would be happy to have you. Follow us on Meetup. Join in on the conversation on Meetup. We'll drop a link to that as well. And if you're on Facebook, we've got a Facebook group and Twitter as well. And then we'll drop a link to our YouTube channel so you can get the video there as well once it's backed up.
Before you cut off, I just want to thank you for doing this, and it was great.
Yeah. Thanks so much for agreeing to come on. Really appreciate it. Jesse, it's always great hearing from you. You're a wealth of knowledge. Very much appreciate it. So, if others want to keep up with what you're working on, follow on Twitter and look at the blog and, read the book, support your booksellers, do all that fun stuff.
Do all that. Yeah. It's at Jesse Liberty on Twitter.
Also, as John was saying, if you want to follow this Twitch channel, we will probably be getting back into some of our other streaming that we do as well. We were doing a live coding Wednesdays that will probably fire up again, and also our podcast on Mondays.
Yep. And with that, we will do the Twitch thing where we will raid our friend over at Jitspo and say good night, everybody. Thanks so much.
Good night.